is Wesley, and you suck at it. Here's what you're going to need to do. What two numbers multiply to give you 36? 1 and 36. 2 and 18. 3 and 12. 4 and 9. 6 and 6. I can't go anymore. Can I take any of those two numbers and add them to get you 13? 4 and 9, right? So those are my numbers, 4 and 9. Now, here it's the same numbers, but we got to get to negative 36, and they got to get to 5. So really what we're asking is the difference, or the distance between two. These are the only ones that have a distance of 5. Well, if it's going to add up to negative 5, the bigger number has to be negative. So that's where the negative 9 and positive 4 come from. Here we have 12. 1 and 12, 2 and 6, 3 and 4. I got to get to negative 1. These are the only two that have a distance of 1. Negative 4, positive 3. What about 25? 1 and 25, 5, 5. I got to get to negative 10. Both have to be negative, exactly. 30. 1 and 30, that's the one people forget. 2 and 15, 3 and 10, 6 and 5, or 5 and 6. Which one have a distance of 7? So negative 10 and positive 3. You'll notice that when these are negative, it's a distance. When it's positive, you're adding them together. Very simple stuff, I think. We'll find out. Now, where does this apply? Well, today I said we're going to talk about the F word. And the best story I have about the F word is there was a principal here named Mr. Pombasai years ago. Now he's the principal at Marshalltown High School. His first year as being an assistant principal, he came walking by my classroom. The doors were open, and it was similar to this. All right, kids, today we're going to talk about the F word. And he kind of stopped, walked in. Mr. Cooley, I heard you say that you're going to talk about the F word. I said, yeah, factoring. What are you thinking about? He just tucked his head, turned around, walked out, and never has been in my classroom since. I don't understand why. So, F word. Use it at home. Little brothers and sisters. Listen here, you little factor. Now, granted, it's a little edgy. It could get you in trouble, but it's funny. Funny stuff. So, what time is it now? Factor time.
Triple F life.
No, I've never heard of that. So, ladies and gentlemen, we are going to factor. You are going to play the game while you factor. Here's what happens. The last number, those are the two that you are looking to multiply. So, two numbers that multiply to give you negative 36 and add to give you 5. So, you're working this direction. Kind of backwards, right to left. So, here we are. We've already done this one. Two numbers that multiply to give you negative 36, add to give you negative 5 are negative 9 and positive 4. Everybody agree with that? So, how am I going to write this? Well, you are going to break this up into two binomials. This is considered a trinomial. We'll spend more time on that in the near future. But a trinomial. Anybody know what separates terms? No. That's supposed to be a plus symbol.
Plus
What else?
minus.
Minus. That separates terms. A trinomial, just like tricycle, has 3 terms. 1, 2, 3. These two are one term right now. They're together. Now they're what? They're separate. 2 terms. 1 term, 2 term. But I got to have a plus or minus in between. So I have 3 terms here. Now, anybody know how to factor? Have you done it in the past? Anybody know what the first term of both of these is going to be?
X.
It is going to be x.
Because it's exponent.
Now, ladies and gentlemen, how do I write this? I know these are my 2 numbers. How do I write it? Minus 9 plus 4. Now, some of you would say, well, what about this? Same thing. Does not matter. It's your thing. Do what you want to do. Check it real quick. First 2, do they equal the first? Yes or no?
Yes.
Do the last 2 multiplied equal the last? Yes or no? Small smile, big smile. Multiply, multiply, and my good friend Adam. Does it equal your middle term? Yes or no? Yes. So it does. This is factored. This is called factored form. Factored form. Let's take a look here. Give it a shot. See if you can factor it. I'll get you started. All of these tonight, you can start this way. I wouldn't say all, 95% of them. 2 numbers that multiply to give you what?
20.
Add to give you? Negative 9. Did we do that one? Nope. Miller, you got it?
Negative 5, negative 4.
Negative 5, negative 4. Everybody agree?
Yep.
Divine, you agree? Well, tell them great job then.
Good job.
No, not good job.
Great job.
That's the answer.
That's factored. Yes, Howard.
What is it when you have to put the opposite?
We'll get to that here in a second.
How did you say you check it?
First 2 equal the first, yes or no, when you multiply.
Oh, okay.
Last 2, yes, 2 smiles. That's how I do it. Factor it, go. I think we've done this one. What's it going to be?
X minus 4x plus 3.
X minus 4x plus 3. I like to rebel a little bit. Who can do E in 1 second? It's done. Isn't it? X, X. Positive 4, positive 9. Done. Now you'll also be asked to solve these. Anybody know what solve means? Find answers. Now, these answers are going to be called not only answers, they're going to be called x-intercepts, solutions, roots, intercepts. They're all the same thing. This is just a lot of different words that mean the same thing. Potato, 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 potato. It's all one of those things that are grown in Idaho. I don't know how you say it. Where I grew up, it was tater. Mashed taters. So, the difference is, these are now going to say equal to 0, equal to 0, equal to 0, equal to 0. That means I got to give solutions. Anytime you have an equal sign, you got to give answers, folks. You got to give solutions. You are 1 second from being done with all of these individually. Now, let's think about it. Intercepts, roots, solutions, da-da-da. We're looking for values that we can put in for x that will make it equal to 0. Now, what did we do over here? What's 0 times 0? So, what would create this first set of parentheses to be equal to 0? 5. There's one of your solutions. What would you create this to be 0? There's your other solution. Now, ladies and gentlemen, here's the $1 million question. How many solutions are there to every quadratic? 2. How do I know that? This exponent right here tells us. What if I had a degree 3? How many solutions? 3. What if I had a degree million? What if I had a degree 6,283? Whittem? How many solutions or how many different would you have? 6,283. Really? What are my solutions here then? -3 and 4. Look at the person to your right. Tell them what those are. Go.
That'd be considered 2 solutions.
What?
Kyle, what's the 2 solutions that Whittem told you?
-4 and -9.
He's correct. Way to go. Now, I'm going to talk one other type of factoring. This is called a difference of 2 squares. 2 squares. I also call them almost twins. Did you know that everywhere, that somewhere in the world there's an exact replica of you? I know, but isn't that amazing? I had to get it on film.
Oh, film.
So almost twins. Almost twins. Take a look.
You should be able to make ads for yourself so like find the other one.
That's a good point. These are exactly the same, aren't they? Exactly the same. What if I did that? Now they're a little bit different. They're almost twins. That's the only difference. Now, factoring a difference of 2 squares, you have to have these 4 checks. Check 1. Is it a minus? Are all 4 of these minus, yes or no? Yes, they are. Hi. Are there 2 terms? Again, what separates terms? Pluses and minuses. If it's going to be a difference, it's going to have to be a minus. 2 terms. Do all these have 2 terms? Yes or no? Yes. Do I only have even exponents? Yes or no?
Yes.
Even itty bitties. 2, 4, 6, 8. Who do we?
Appreciate.
Last one, perfect. What do I mean by perfect? Jace, tell us.
Big squares.
Perfect squares. Give me an example.
9.
9 is a perfect square. Now, Jace, that's amazing that you can describe perfection without a mirror. That's awesome. Good job. Divine's going. I don't know how anybody does it without a mirror. Johnson, how are you going to do? Do you even know what I'm talking about?
Yeah.
But I was complimenting you all.
Yeah.
So, ladies and gentlemen, perfection, 4, 9, 25, 36, da 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 da. How do I factor a difference of 2 squares? First of all, it's got to have all those. Is it a minus, yes or no? Is it even exponents, yes or no? 2 terms, yes or no? Perfect, yes or no? It's going to break up into 2 terms. 2 factors, excuse me. What's the first of both? X. What's the last of both? 7. I'm going to go ahead and make them exactly the same, but somewhat different. Done. What's this one going to do? What's the first term of both? 3x. In this case, 3x. What's this one going to be? 4 and 4, minus and plus, does not matter which order. Because look what happens when I multiply these 2. First 2, x squared. Last 2. What happens to my 2 smiles? What happens to my 2 smiles? They eliminate, they're gone. Negative 5x, positive 4x.
What do you give me?
Last one we'll do today. Two binomials. 2y to the what?
4.
2y to the second. Cut
Second,
it in
just
half.
kidding.
Yep. 2y squared. What's the last term of both? 5. What goes in between? Minus plus or plus 5, so your choice. Assignments on the block. Quiz tomorrow.